Hello, my name is Dr. Yaya Sissoko, Professor of Economics, Department of Finance and Economics, Indiana University of Pennsylvania. Today, we're going to talk about Chapter 6, Human Capital. This video is about estimating the rate of return to schooling. So how do you estimate the rate of return to schooling? The typical method for estimating the rate of return uses data on the earnings and schooling of different workers and estimate the percentage wage differential associated with one or more years of schooling after adjusting the data for differences in other worker characteristics. A typical empirical study estimate a regression of the form log of Wi equal to A plus B times Si plus other variable, where W is a wage rate, S is a year of schooling, B is the coefficient that estimate the rate of return of to an additional year of schooling. A is the constant. What is the evidence in the empirical studies? So in studies of twins presumably holding ability constant, valid estimate of rate of return to schooling can be estimated. Estimates range from 3% to 15% annual rate to a year of education. Generally, the rate of return to schooling is higher for workers who were born in states with well-funded education systems. The graph about the school quality and the rate of return to schooling illustrates some of this evidence. The decennial census data reported that the current earning of workers born in the particular state are, we can then run the regression model from the previous slide using this sample of workers. The regression coefficient presumably measures the rate of return to school in state R, this one, by replicating the exercise for each of the 50 states. We get a complete picture of how the rate of return differ across states, allowing us to determine if the variation is related to differences in school quality. The figures show the relationship between the estimate rate of return R shown on the y-axis and the average public teacher ratio showing on the x-axis in the state at the time the student went to school. Children born in states that offer better schools, at least as measured by a small class size, had a higher rate of return to school after they enter the labor market. We can see that the linear regression here between the rate of return and the public teacher ratio, the class size here, linear regression is so as the number of the ratio student to teacher increases. In other words, as the class size increases, the rate of return decreases. For instance, on average, if the class size was about 25 here, the rate of return was about 5.2%. If the class size is 30, the rate of return is only 5%. If the class size is 35, the rate of return is only 4.8%. And if the class size is say 37, the rate of return is 4.7%. For instance, we have an outlier here where the class size is 20 only student per teacher. The rate of return was about 7.1%. And then here the class size here is another outlier. The class size is about 34. The rate of return is only 3%. So we can conclude that children born within the state that offer better school, at least measured as a small class size, had a higher return to school when they entered the labor market. So next, let's ask the following question. Do workers maximize lifetime earnings? The schooling model assumes that workers select their level of education to maximize the present value of lifetime earnings. To test this hypothesis directly, we must observe the age earnings profile at 2 points in time. Unfortunately, once a choice is made, we cannot observe the earning associated with the non-choice. That using the observed wage differential to determine if the worker select the right earning stream yield meaningless results. Also, schooling can be considered as a signal. The schooling model is based on the idea that education increases a worker productivities, and this increase in productivity will raise wages. An alternative argument is that education does not increase productivity at all, and the level of education, in other words, education reveals a level of unattainment which signals worker qualification or innate ability to potential employers. Information that is used to allocate workers in the labor market is called a signal. There could be a separating equilibrium, meaning what? Low productivity workers choose not to obtain X years of education, voluntarily signaling their low productivity. High productivity workers choose to get at least X years of schooling and separate themselves from the pack. Now let's analyze the graph about education as a signal. In panel A, the low productivity worker, so we can see that this worker get paid $200,000 a year if they get less than Y bar year of college. So if they get less than Y bar year of college, they get paid $200,000. And $300,000 if they get at least Y bar years of schooling. So if they get at least Y bar year of schooling, they get paid $300,000. So low productivity workers find it expensive to invest in college, and they will not get Y bar years, because you can see that after Y bar years of schooling, the cost which is the slope of this curve is $25,001. So they will find it more expensive to go to college. However, in panel B, high productivity worker, so these high productivity worker do obtain Y bar of schooling or college. So Y bar of schooling or college, they get paid $300,000, and then the cost of going to college is the slope of the graph, which is $20,000, so which is cheaper than the one for low productivity worker, which is $25,001. So therefore, the worker education signal, if he is a low productivity worker, this graph panel A, or a high productivity worker, panel B. Finally, what are the implications of schooling as a senior? There are three main conclusions we can draw from schooling as a senior. The first one, for schooling to act as a senior, school must be more costly for low ability worker compared to high ability worker. The second conclusion is that social return to schooling percentage increase in national income is likely to be positive even if a particular worker human capital is not increasing. The last and final one is that although education may incorporate a signaling aspect, it is well accepted that education is more than a signal. Education is at least partially an investment in human capital. This is the end of the video about estimating the rate of return to schooling. Next time, we'll talk about labor demand and the production function. Thank you.